have two functions, f and g. F is 1 over x plus 3, and g is x squared minus 4. F of negative 2 means plug a negative 2 into the f function for x. So f of negative 2 would be 1 over negative 2 plus 3, which is 1. And g of negative 2, plug a negative 2 into g for x, and I get negative 2 squared minus 4 is going to be 4 minus 4, which is 0. The domain of f is the set of all x values that you are allowed to plug into f. So the only restriction I have on f is the fact that this thing is a fraction, and the denominator of a fraction can't be 0. So if I set x plus 3 equal to 0 and solve, I get a value of x that I cannot plug into f. So my domain of f is every value except that one. There are two ways to write this. Set builder notation would say the set of all x's such that x cannot equal negative 3. And interval notation, which is what you are used to if you've been using my math lab, would say negative infinity to negative 3. Don't include the negative 3 because it's not part of the domain. And then union that with negative 3, not including the negative 3, to infinity. The domain of g is all real numbers because g has no restrictions. You can square anything you want. There are no restrictions on x squared minus 4. So you could write all reals, or you could write negative infinity to infinity. All right, so now I want to do a couple of compositions. F of g of negative 2. Well, g of negative 2 I can replace with its value that it equals. We calculated it earlier to be 0. So I want to calculate f of 0, which is 1/3. And then g of f of negative 2, I can replace f of negative 2 with 1. So I'm calculating g of 1, which is 1 squared minus 4 is negative 3. And then I want to find an equation and the domain for f of g of x. Okay, so f of g of x, that would be f of, replace g of x with its formula, x squared minus 4. And then put an x squared minus 4 into the f function wherever you see an x. So I have 1 over, instead of x, I put x squared minus 4, and then plus 3. And that is going to be 1 over x squared minus 1. So there's my formula. To calculate the domain of a composition, I like to draw a picture, f of g of x, as a succession of function machines. So I'm going to start with the g machine, because that goes first, and then draw the f machine. And I say, okay, x's are going to go into g, and it has no restrictions. And then g of x comes out, right? It's going to take that x and turn it into an x squared minus 4. And I take this x squared minus 4 and drop that into the f machine, into which I can never put a negative 3. So I have to make sure my restriction here is that x squared minus 4 can never be negative 3. Otherwise, I'll jam the f machine. So if I solve this thing, I would say, well, that means that x squared can never be 1, which means that x can never be plus or minus 1. So if I start back over here at the very beginning, I can't put a 1 or a negative 1 in there, because if I do, I would get a negative 3 out, and then the f machine would jam. So my domain of the composition is all reals except for plus or minus 1. So I would write that the set of all x's such that x does not equal positive or negative 1. And you could put that in interval notation if you want.